Hello, friends. Here is a question worth thinking about. When your computer runs an if statement and decides whether to do something or skip it, what is actually happening at the lowest level? The answer starts with just two values, true and false, or 1 and 0. And the tool that maps every possible combination of those values to an output is called a truth table. Truth tables are a core tool of Boolean logic, the same logic that powers every circuit, every condition, and every decision your computer makes. By the end of this video, you will be able to read any logical expression and build its truth table from scratch. Let us start by understanding exactly what a truth table is. A truth table is simply a grid. Each row represents one unique combination of input values, and the final column shows the output for that combination. Every input is Boolean, meaning it can only be 0 or 1. Now, if you have one variable, you get two possible values, 0 or 1. That gives you 2 rows. Add a second variable, and the combinations double, giving you 4 rows. The pattern is 2 to the power of n, where n is the number of input variables. 2 variables give you 4 rows. 3 variables give you 8 rows. 4 variables give 16 rows, and so on. This guarantees that every possible scenario is covered. No input combination is missed. With that structure in place, let us now look at the 3 core logical operators and fill in those output columns. Now, let us walk through each operator one at a time. Not is the simplest. It takes one input and flips it. 0 becomes 1, 1 becomes 0. That is it. And takes 2 inputs and returns 1 only when both inputs are 1. Any other combination gives 0. Think of it as strict. Both sides must be true. OR also takes 2 inputs, but returns 1 when at least one input is 1. Only when both inputs are 0 does OR return 0. So AND is strict, OR is generous, and not just inverts. These 3 operators are the building blocks for every logical expression you will ever encounter. Once you have their tables memorized, you can evaluate anything. Next, we will combine these operators into a single expression and trace through a multi-column truth table, step by step. Now, let us combine operators. Take the expression A and not B. We have 2 input variables, so we need 4 rows. Start by listing all combinations of A and B. Then add an intermediate column for not B. This is the key move. Resolve the innermost operation first, just like order of operations in arithmetic. Not B simply flips B. When B is 0, not B is 1. When B is 1, not B is 0. Now apply AND across A and not B. AND returns 1 only when both sides are 1. Looking at the table, only row 3, where A is 1 and B is 0, gives not B as 1, so AND returns 1 there. Every other row gives 0. Breaking a compound expression into columns like this makes even complex logic manageable. Let us wrap up with why this all matters. So here is the full picture. A truth table is a complete map of a logical expression. You list every combination of inputs, 2 to the n rows for n variables, and then evaluate each operator column by column, innermost operations first. This is not just theory. On the hardware side, logic gates in a chip implement these exact tables physically. On the software side, every if condition in your code is evaluating Boolean logic. The expression A = 1 logical AND not B in code maps directly to the A and not B table we just built. The one-line rule to remember is simple. List all input combinations, then evaluate one column at a time. That is truth tables, start to finish. Thanks for watching. If this helped, give the video a like, and we will see you in the next one.